Look up at the night sky. What do you see? Tiny twinkling points of light, stars, the moon, maybe a planet or two. But you're not just seeing light, you're seeing history, the past, carried across space. Many stars are so distant that their light has traveled thousands, even millions of years to reach you. Some of those stars are cosmic time bombs, waiting for their final spectacular act. Deep within, they fuse elements, releasing energy that pushes outward, fighting gravity's inward pull. For eons, this balance keeps the star shining. But the fuel runs out, the balance breaks. When that happens, the star's destiny arrives in a flash of unimaginable power. Imagine a star much more massive than our sun, burning through hydrogen, helium, carbon, oxygen, silicon, until it reaches iron. Iron is a dead end. Fusing it consumes energy instead of releasing it. Suddenly, the outward push stops. Gravity wins. The star's core collapses in less than a second, squeezing into an object of incredible density. The outer layers crash inward, then rebound off the core, creating a shockwave. The shockwave tears through the star, heating it to billions of degrees. The star detonates, outshining its entire galaxy for weeks. This is a supernova, the universe's ultimate firework. It's the most violent event since the Big Bang. But it's not just an ending, it's a profound beginning. In that explosion, the star's elements are scattered across space. New stars, planets, and even life can form from this cosmic debris. Every supernova is a story of life, death, and spectacular rebirth. The night sky is filled with these stories, some already told, some yet to come. So next time you look up, remember, you're witnessing the universe's greatest drama. The stars above are not just lights, they are the echoes of ancient cataclysms. And somewhere out there, another star is preparing for its final, breathtaking farewell. The universe is always changing, always renewing itself, and we are here to witness it. So what exactly is a supernova? The name comes from nova, Latin for new, because ancient astronomers saw new stars appear. Supernova means a truly massive one. A supernova is the explosive death of a star, releasing more energy in seconds than our sun will in its entire lifetime. It's nature's way of going out with a bang. Imagine a massive star, always fighting gravity with the energy from nuclear fusion in its core. For most of its life, gravity and fusion are in balance. But when the fuel runs out, gravity takes over. The star collapses in a fraction of a second. The outer layers fall inward at incredible speeds, slam into the dense core, and rebound. This creates a shock wave that triggers the explosion. The star is torn apart, blasting its material into space. The explosion is so bright it can outshine an entire galaxy for a short time. Sometimes supernovas are visible even during the day. But this light is more than a spectacle. It carries the story of the star's life and the seeds of future creation. Supernovas are the universe recycling itself in the most spectacular way. They are beacons in the cosmic ocean, announcing the death and rebirth of a giant. Every supernova is both an ending and a new beginning. The universe's grand finale is also its next overture. Not all stars end in a blaze of glory. Our sun is too small for a supernova, but for those that do, there are two main types, Type 1 and Type 2. Type 2 is the classic death of a massive star, at least 8 times the mass of our sun. These stars live fast, die young, and end with a core collapse and a spectacular explosion. Type Ia supernovas are a different story, a cosmic partnership. Here, a white dwarf, the dense core left after a sun-like star dies, orbits a companion star. The white dwarf steals material from its neighbor, growing heavier. When it reaches about 1.4 times the mass of our sun, the Chandrasekhar limit, it can't support itself. A runaway thermonuclear reaction ignites, detonating the star. Type Ia supernovas always explode at the same mass, making them reliable standard candles for measuring cosmic distances. Both types are powerful, but their origins are very different. One is a solitary giant's end, the other a dramatic cosmic theft. These explosions shape galaxies, create new elements, and help us map the universe. Supernovas are not just endings, they're cosmic milestones. Each type tells a different story about how stars live and die, and both are essential to the universe's ongoing evolution. Without supernovas, the cosmos would be a much emptier place. They are the universe's way of renewing itself, and they remind us that even in destruction, there is creation. When the supernova's light fades, what remains? The explosion creates a beautiful nebula, a glowing cloud of gas and dust, the star's final masterpiece. At the center, the core's fate depends on the star's mass. If it was 8 to 20 times the sun's mass, the core becomes a neutron star, an object so dense a teaspoon would weigh 1 billion tons. Some neutron stars spin rapidly, beaming radiation as pulsars. If the star was even bigger, gravity crushes the core into a black hole, a region where not even light can escape. Supernovas leave behind nebulae, neutron stars, pulsars, or black holes, cosmic wonders born from destruction. These remnants enrich space, seed new stars, and shape galaxies. The death of one star creates the building blocks for countless new stories. In the universe, every ending is a new beginning. Why do supernovas matter to us? Because they made us. Every atom in your body, except hydrogen and helium, was forged in a star and scattered by a supernova. The calcium in your bones, the iron in your blood, the oxygen you breathe, all born in stellar explosions. The Big Bang made only the lightest elements. Stars and supernovas made the rest. Supernovas blast these elements into space, enriching clouds that form new stars, planets, and life. We are literally made of star stuff. Walking, talking collections of cosmic debris. The universe is not just out there, it's in us. Every breath, every heartbeat is a connection to ancient stars. We are the children of supernovas, part of the universe's ongoing story. The cosmos is within us, and we are its legacy. Humanity has watched supernovas for millennia, long before we understood them. Ancient astronomers recorded guest stars that appeared, shone brightly, then faded. Supernovas in our own galaxy. The most famous was in 1054. Seen worldwide and visible even in daylight. Today, we know it as the Crab Nebula, a beautiful supernova remnant with a pulsar at its heart. In 1987, SN 1987A exploded in a nearby galaxy, giving us an unprecedented look at a supernova in real time. We detected neutrinos before the light, watched the blast echo off dust, and confirmed our theories about stellar death. These events connect ancient records with modern science. Supernovas are not just cosmic events, they're part of human history. Each one teaches us more about the universe and our place in it. Betelgeuse, the red supergiant in Orion's shoulder, is a star nearing its end. If placed where our sun is, it would engulf the inner planets. It's a prime candidate for a future supernova, just 650 light-years away. In 2019 to 2020, Betelgeuse dimmed dramatically, sparking speculation. But it was just a dust cloud. The star is unstable and in its final stages. But soon in astronomy could mean tomorrow or 100,000 years from now. We know it's burning heavier elements, inching toward its explosive finale. When Betelgeuse goes supernova, it will outshine the full moon, be visible in daylight, and cast shadows at night. It will be a spectacular, harmless show for Earth. Future generations will record their own guest star in history. Until then, we watch and wait for Betelgeuse's final act. It's a reminder of the universe's power and unpredictability, and it will be a sight no one will ever forget. Could a supernova threaten Earth? The answer, almost certainly not. For real danger, a supernova would need to be within 50 light-years. No stars that massive are anywhere near us. Our cosmic neighborhood is safe. No nearby candidates for a deadly explosion. Betelgeuse, the closest, is over 600 light-years away, far outside the danger zone. When it explodes, we'll get a light show, not a threat. The radiation will be harmless by the time it reaches us. Supernovas are engines of cosmic recycling, not cosmic threats. We're lucky to witness them from a safe distance. They remind us that the universe is always changing, but we are safe in our quiet corner. The story of a supernova is the story of the universe, life, death, and rebirth on a cosmic scale. These explosions are woven into our existence. Every breath contains atoms forged in ancient stars. We are stardust, given life and the ability to wonder. When you look at the stars, see them as cosmic ancestors, giant furnaces that made you possible. The iron in your blood, the calcium in your bones, are testaments to stars that lived and died long ago. In their violent ends, they created new beginnings. The universe exploded into being, and it continues to explode within us. We are the living legacy of the stars, a reminder that endings are also beginnings. And that is a truly wonderful thing to be.